Welcome to FRIDAS, a new framework setting data management standards for Biodiversity Net Gain submissions. Biodiversity Net Gain, or BNG, was officially launched in February 2024 after being passed by the Environment Act. It is now mandatory under the Town and Country Planning Act 1990 for all major developments in England. BNG ensures that habitats are left in a measurably better state post-development with a minimum of 10% net gain. Post-development, habitats need to be monitored for 30 years to ensure ecological improvements promised during the planning process are actually delivered and maintained long-term. Calculations rely on standardized metrics where area plays a critical role, and the most accurate way to measure land parcels is through Geographic Information Systems, or GIS. Despite policy development progressing, we still face a fundamental gap. There is no mandatory standardization for GIS data submission to support BNG assessments. This lack of standardization risks misalignment between datasets, introduces errors into biodiversity calculations, and places an increased burden on local authorities to manually check and interpret non-standard submissions. Recognizing this challenge, Spatial published a white paper in January 2025 titled Addressing GIS Data Standards in BNG Management. This research recorded the problems faced by local planners and BNG operatives, reviewed principles of geospatial data quality, and proposed a dynamic checklist solution designed to bring standardization and rigor to GIS data for BNG. Our research identified that around 25% of local planning authority-approved BNG submissions contain significant GIS errors. The absence of standardized GIS protocols for BNG assessments has significant consequences. First, submitting incompatible file types can delay application reviews and introduce errors during data processing. Without a clear coordinate system, spatial data may misalign, affecting the accuracy of biodiversity calculations. Boundary delineation errors, where the red line does not match the land registry records, can result in overlaps, gaps, and legal complications. Inconsistent or manual digitization practices, such as not snapping polygons, cause duplication of units or missing habitat areas altogether. Variable habitat classification also undermines assessments. Skipping proper habitat verification or misclassifying habitats can lead to deliberate or accidental inaccuracy, ultimately reducing the real-world biodiversity enhancements achieved. The lack of metadata further damages transparency and removes the capacity for data auditing, weakening the credibility of assessments. Incomplete or inconsistent attribute data can make datasets non-compliant with Natural England's biodiversity metric requirements. Finally, current policy often omits slope considerations. Without accounting for slope, we risk underestimating habitat areas on inclined terrain, leading to inaccurate BNG scores and poor ecological representation. Artificial intelligence is making its way into biodiversity planning. From habitat mapping to remote condition assessments, AI offers promising tools that could streamline data processing and support large-scale ecological evaluations. But these tools are only as reliable as the standards and checks that surround them. Without clear data standards, AI-generated outputs risk becoming black boxes, difficult to audit, replicate, or trust. Algorithms may misclassify habitats, apply incorrect labels, or produce output that are disconnected from ecological reality. All of these challenges raise a fundamental question: how can we trust the BNG scores being reported? Through robust data standardization, we can ensure GIS data is not just acceptable but accurate, verifiable, and ready for reliable BNG assessments. To address these challenges, we developed FRIDAS, a powerful, robust framework composed of 6 elements of data management for user-focused approach to data standards. They are format, red line boundary, identification, data, attributes, and slope. FRIDAS is designed for anyone involved in delivering high-quality spatial data for BNG success. Whether you are conducting baseline habitat surveys, designing development proposals, managing off-site offsetting schemes, or operating habitat banks. FRIDAS is not just a static standard, it's a flexible framework designed to adapt as planning policy, biodiversity metrics, and geospatial technologies evolve. The FRIDAS checklist guides users through each data quality dimension, using targeted questions for each of the 6 categories. It ensures that all critical elements, from format to slope, are considered, recorded, and traceable, helping LPAs and applicants build a stronger, more defensible evidence base. The first category of FRIDAS is format. In simple terms, this ensures your spatial data is actually usable within a GIS system. Data for BNG assessments should be submitted in a standard GIS format, such as ESRI shapefile, GeoPackage, or GeoJSON, alongside any supporting PDFs. This standardization minimizes errors in data exchange and conversion, enhancing both the accuracy and precision of spatial data. Additionally, the coordinate system must be consistent, specifically using the British National Grid. All layers should be logically structured, clearly named, and ideally packaged together in a single GeoPackage or zip archive, accompanied by a layer list. Checklist questions for format include: what is the format of your data? What is the spatial reference system of your data? The next category is the red line boundary. The red line boundary defines the legal footprint of a development and forms the basis for all biodiversity net gain calculations. For accurate assessments, this boundary must precisely match land registry records, be consistently used across all datasets and figures, be clearly named, for example, as red line boundary. Where discrepancies exist, such as mismatches between baseline and post-development boundaries, it can result in missing habitat units, overestimated gains, or legal disputes. Drawing the red line boundary within a GIS environment ensures greater positional accuracy and consistency. Checklist questions for red line boundary include: is the same red line boundary used across all datasets and figures? Does your red line boundary fall within the relevant land registry boundary? Has the red line boundary changed since doing initial baseline surveys? If yes, has this versioning been incorporated into the file name? Where possible, a map or screenshot should be provided as evidence. The third FRIDAS category is identification. Errors around habitat identification are surprisingly common and can severely undermine the validity of a BNG assessment. Accurate identification means ensuring that habitats are classified using the UK Habitat Classification System, UKHAB, are verified through on-site ecological surveys, avoid gaps, overlaps, or logical inconsistencies in their GIS representation. Aerial or satellite imagery can supplement field surveys but cannot replace on-the-ground verification, especially for dynamic habitats or recent land use changes. Additionally, polygon features must be closed, correctly snapped, or should not cross linear infrastructure features like roads or rivers unless intentional. Checklist questions for identification include: has OS master map been used to digitize polygons? Has the habitat identification been verified using field surveys and imagery? Are there gaps between habitat parcels? Do habitat parcels overlap? Has any processing within the assessment used AI? If yes, please describe and ensure corresponding metadata accompanies your submission. The fourth category is data, including supplementary information and metadata. This is often one of the most overlooked but most critical elements of GIS data quality. Metadata should capture key details such as the surveyor or author, survey and digitization dates, data sources, spatial reference system. Ideally, metadata should comply with Gemini 2.3 standards to ensure consistency, transparency, and usability. If a project does not have habitats surveyed by an ecologist, it's vital to reference supplementary datasets used to support classifications, such as local nature reserves, SSSIs, or historic land cover records. Comprehensive metadata and clear references to supporting data strengthen the integrity of BNG assessments and allow future users, including LPAs, to trace and verify the information. Where AI has been used, the metadata must also document model name and version, input imagery and resolution, training and validation methods, ecologist review and approval, assumptions or limitations. Checklist questions for data include: are there any supplementary datasets included as part of your site data? Was your site surveyed by an ecologist? If not, what supplementary information supports your site classification? Have all mandatory metadata elements been recorded? If AI-generated data is used, key information must also be provided, including the model used, data inputs, validation methods, and ecological review. The fifth category is attributes, the descriptive fields stored within your spatial data. Each polygon representing a habitat must be accompanied by a complete set of attributes. These should include fields such as habitat type, condition score, distinctiveness score, area in hectares, any other variables required by the biodiversity metrics. We recommend using the QGIS biodiversity metric template or adhering to the Natural England GIS data standard to structure these attribute tables. This ensures consistency, reduces interpretation errors, and facilitates efficient integration into biodiversity metric calculations. Checklist questions for attributes include: which materials from Natural England have been used to develop your GIS data? And finally, the sixth category is slope. Although slope is not yet a formal part of the official biodiversity metric, it plays an important ecological role. Slope affects factors such as water runoff, erosion, vegetation growth dynamics. By incorporating slope analysis into your BNG assessments, you can provide a more ecologically realistic evaluation of habitat conditions, particularly on sites with varied terrain. Slope should be calculated using high-resolution digital survey models, DSM, or LiDAR, ideally at 30 cm resolution or finer. Even though it remains supplementary, including slope data improves completeness and transparency, strengthening the robustness of BNG outcomes. Checklist question for slope includes: what is the approximate range of slope that your data covers? To help users apply these standards and improve GIS data quality, we offer a full range of resources including detailed blogs exploring specific challenges and best practices, interactive story maps to visualize concepts in action, informative carousels breaking down key elements, and tailored training and data review services to support planning applications. Whether you're new to GIS for BNG or looking to improve your processes, these resources are here to support you. To learn more about FRIDAS, access our free resources, or discuss how we can support your organization, please get in touch. Email us at fridas@ecospatial.co.uk or visit our website at www.ecospatial.co.uk/fridas. You can also follow Ecospatial on LinkedIn for regular updates, case studies, and insights into the evolving world of biodiversity data management.